I'm still a student at BYU studying computer science, and I currently work at Domo. Something I love is distributed systems and performance profiling. Something I hate would be front-end web because it's gotten so complicated and gross in the past year or two with so many configurations and tools that require Babel, Webpack, and it's just way too complicated and gross now. So I like the terminal, things that don't have user interface. Okay. So today I was going to talk about Celery. Has anyone here used Celery before? Okay, you're one person.
A little
bit.
I've seen it, but I heard of it before.
Seen it, heard of it. Cool. Okay. Cool. Perfect. So, I want to start out. It's a task queue, but what really is a task? Simply put, it's a function you want to do. It could be a database transaction. It could be an API call. It's some particular thing you want accomplished. Something that we all know would be a function or a set of functions. So Celery advertises itself as an asynchronous distributed task queue, which is kind of a mouthful. So to understand all that, it's asynchronous, meaning it's running outside of your main loop, your main thread. It's distributed, which makes it scalable, so you can spin up more machines if you need more processing power. And it's a queue in the data structure we all know as first in, first out. So basic API functionality, someone sends an HTTP request to a server. Server has stuff to do, and it sends an HTTP request or HTTP response back. It's single-threaded, it's sequential, and so if the server has a lot of things to do, then the client is going to be stuck waiting for quite a while before it can get that response back. And to demonstrate that with a lot of pictures of celeries for some reason, because there's a lot of celery on the internet, the client can easily just be stuck waiting until it finally gets some response. So another use case where you might be stuck waiting for things is if you're sysadmin or you're DevOps and you have all these computational tasks that you need to run.
You push that and that might help. Everything's in spacebar.
Cool. Yeah. So two solutions for handling all these things to do is you can either try multi-thread, which if you've been with Python long enough, you know that only sometimes works depending on what you're doing due to the global interpreter lock. Or you can try to use Celery to offload your workload to other machines to do and then come back to you later when those tasks are done. The multi-threading solution is fairly easy, straightforward in Python. This is a very short multi-threaded program that I wrote up. And for I/O-bound computing, it actually works fairly well. So in this case, the program is just making a bunch of HTTP requests, and because it's multi-threaded, while those requests are going, it can actively work on those other requests that it needs to send off. And multi-threading it will decrease time for you. However, with the global interpreter lock, CPU-bound requests don't get the same benefit. So in this case, I did a very basic Fibonacci sequence, not optimized at all, just very basic recursive function. And when I tried a multi-threaded version of that same function, it increased the time by 40 to 43 seconds, rather than speeding things up. And so is everyone familiar with the global interpreter lock? Why it's running single thread? What was that?
Super annoying.
Yes, it is. And actually, when I look for the reason why they had a global interpreter lock, all they would say is like it's easier on the people who write the runtime. Like,
oh, it technically is. There's a Eric Snow who comes here sometimes has a fix that he's working on to handle multi-threaded and non-CPU bound things or CPU bound things, and then make them work within the structured global interpreter lock, a different GIL. It goes what's called a sub-GIL basically, and it runs all that in there, so you can run in tandem. But it's a tricky way of getting around it.
Yeah, it sounds pretty hacky.
Yeah, but apparently it's pretty solid, and he thinks it's going to work, but he hasn't gotten tons of code around yet to test it. So.
Yeah, for CPU-bound requests or CPU-bound tasks, they probably want some other way to make this go faster. So this is where Celery comes in, and we're just going to jump right into demo because I think demos are the best way to demonstrate something. That's the main demo. And let me pull up the code real quick so you can see what we're doing. Okay, so here's a very very, very basic Celery setup. So the way Celery works is that you have a broker, which is basically your message queue. Celery supports a huge variety of different brokers. There's Redis, RabbitMQ, you can use Amazon SQS, MongoDB, MostSQL databases.
Does it support like etcd?
Was it?
Does it support etcd?
I do not know.
Okay, I'll put that one.
Yeah. I chose Redis because it's the one I'm most familiar with. I've used RabbitMQ before as well. So it's pretty easy to set up. So the way that this program works is you define tasks that you want Celery to be able to run, and then you spin up your Redis server. Get the demo running here. Make this bigger for one. Okay. So I'm just going to run the Redis server in the background. Running. Oh, that was the one. So I have Redis running, and if I pull in, so basic, hello, and then in this other terminal here, I'm going to run the worker. So with Celery, you have worker processes that take on tasks. So the workflow of Celery is that you stick jobs and to be done into this queue, and then workers are constantly checking that queue for things to do. It's pretty basic producer-consumer type pattern. Celery, basic, worker, and just to show. Okay, so here we have a worker process. It is unfortunately all alone because I only have one process going. And it's listening to my local Redis server. And in this Python terminal here, if I call delay on this task, that's how you call the task to run through Celery. So I don't have any arguments to pass to it, so I just run it as is. And we can see that the worker process saw that task needs to be done and executed it. And this thread was not affected at all by that computational time. This was a very basic example where all it does is print hello world in the worker process. Any questions so far? So here's a graphical example of what is happening here. In the program, you say, hey, I need these tasks to be run. They get stored in the broker, and the workers just pick them up as they're available. Pop up from the queue. I already saw this. Show that. So as I mentioned earlier, if the distributed part of it is that if you're getting a lot of tasks built up in your broker, all you do is spin up more worker processes to handle those tasks. And I'm going to demonstrate that in a bit. Before that, there are often instances where you actually want to get the result of those tasks as well. So in this example that I just did, it ran the task, but I didn't really get anything back. And on this side, I just kind of assume that whatever happened is happening, and I'm not concerned with the result. However, there might be the case that you actually want to know what the result was. So I put together another task here that does a terrible implementation of the Fibonacci sequence and will tell us what that answer is. Sorry, what is this one called? Okay, so this worker is ready to go. So I'm going to call the delay function again. This time I do have arguments to pass. So I'm just going to pass it 30 number. And so now if I, sorry, I actually messed that up. And that's going to take a while to run because it's terrible implementation. Okay, try this again. So I'm going to set the result of this to a variable called res. And now I can check if the res is ready at any point. I should probably put a 2-item number because it's not going to be ready for a while. But once it is ready, we can call get on it.
What is the
Sorry?
What is the 30 you're passing?
Ooh, the 30, oh.
Yeah,
Broken pipe.
I love broken pipes.
maybe you should do a lower number.
Yeah.
I didn't see what the 30 represented as well.
Oh, the 30 is what's being passed into my task.
Oh, I see, okay. Which is why, because it's a very inefficient Fibonacci sequence.
Very. That's a smaller number. Okay, so it's already ready. It already finished the answer here. If I just call get, it'll tell me what the answer is, what the result of the execution is. All right, so up to this point, I have demonstrated very basic single worker implementations. So we're going to move on to something a bit more fun. If I can find my slides. There we go. Oh, I didn't show the code very well for that. So to add the backend, it's just an additional named parameter to your Celery application here. And so you can specify different backends and brokers. If you want to use RabbitMQ for your broker and Redis or Mongo for your backend, that's perfectly okay. In this case, I'm using the exact same process for both, which is not the optimal setup. All right, so for the last demo that I have, I spun up 5 DigitalOcean instances. One of them is a Redis server, and the other 4 are going to be worker processes, and we're going to look at how those accept tasks, essentially. Let's see, this one? Yes, okay. So here I have, I probably should have done this beforehand. Worker info. Let's just copy and paste this to speed things up. What happened here? Oh, I need the wrong thing. Demos just never seem to go well live. Receive and register task. Right. Let's try it. There we go. Okay, so now I have all 4 of these servers running. So here you can see that they're all synced up with each other. So synced up with 1 node, synced up with 2 nodes, and the last guy synced up with 3 nodes. And now all 4 processes are ready to accept jobs. And so the final demo I have here is once again a terrible Fibonacci implementation. What I'll be doing is generating 100 random numbers between 12 and 28 to run this terrible Fibonacci on, and put in the task queue, and then we're just going to constantly poll for tasks that are ready to show what the answer is. And we'll see that get executed. Sorry, I want before the start. Okay. So it's adding all of these numbers into the queue, and if we look over at these worker processes, we can see them churning away at Fibonacci answers. And once it finishes adding all these, so now it's going to start putting out the results that are ready. So all of these were already done by the server. Now we're waiting for more to get completed by these 4 worker processes. So Celery is super easy to set up a distributed working pool. Any questions so far? And we're about to finish. Some other cool features with Celery is that you can do things like okay. You can check.
I always think that one's fun.
You can check various tasks or various things about the worker processes. So if you check, let's see, Celery final. Spect status. Oh, just kidding. Quick break to check the docs real quick. If I can find them. Not that either. Oh wait, sorry. Inspect. Let's inspect active. There's various ways you can check on the statuses of different work processes through the terminal. And the next thing I want to show you guys is a tool called Flower, hence the random word. Yeah, dog. Okay, so there's a really cool tool out there called Flowers, which is a live way to monitor all the worker processes in a nice little web GUI. And draw ports. Okay. Now, if we open up localhost, here. Okay, so here we have a little GUI version where we can monitor the 4 worker processes. And if I start up these tasks again, you can actually see these numbers. Yeah, change live. The Flower library is built on Tornado, and so it's somewhat real time, mostly poll based. You can see which process started, so it's working on 25, finished these 2.
So those last 4 basically are the long ones running.
Yeah. Yeah, I'm going to see the longer ones for a while. It's not a terribly complicated GUI, but it is kind of nice compared to memorizing all the commands. So it looks like done.
1 or 2 left. Yeah, well.
Yeah. So that's the Flower GUI. It's kind of a case study of where Celery can be useful. So before I worked at Domo, I was working at a custom dev shop that Domo contracted to build its application, and I got put on the job. And essentially, it's a application for signing in guests, and it has an iOS app that the visitors interact with, and a web app that the receptionist uses. And when a visitor comes, being as secretive as Domo is, everyone has signed an NDA on the iPad. And a lot of people at Domo really wanted us to generate these documents with those signatures as PDFs that we can then keep and refer to if necessary. So when a user comes, they make their signature on the iPad, which we would store as an image and stick that onto some HTML. And then the back end of the project was powered with Django. And so on the server, I would use this tool. I think it was called WK HTML to PDF or something along those lines. That would generate PDF from that HTML. The document, being legal documents, was quite long. And so it wasn't ideal to have that run every time on a request where we were sending out signatures. So what we did is spun up a second instance with a Celery worker, and whenever someone would come in and sign in the signature, the HTTP request would go, and then we would send that signature off to the Celery worker to generate that PDF and push it up to S3. And then meanwhile, we can immediately return back to the iPad and say, okay, yeah, keep going. Don't get caught up on this. So that's kind of a use case that I found was useful. And we did it without checking the results. Rather on the worker side, that's where we checked, did the PDF work? No, okay, try 3 more times. And if that doesn't work, stick it into kind of log file and email the admin so that we know this PDF failed. So in my opinion, generally speaking, Celery is a lot more convenient to work with when you don't have to check the results. As I noted here in this last example, whenever you do want to check the results of multiple tasks, you kind of have to set up a little checking loop here since it's not event driven per se. So I think it's just easier if you can say, do this and do it. And then I'll just go back to whatever I was doing before. And so a couple more notes. Celery is usable in a variety of languages. There's implementations for Ruby and Java and such. Celery itself is written in Python, but it has API bindings for several different languages. They have a special Django library for Django projects. I actually have not used it. It was released after I worked on that project for demo. And yeah, those are comments I have on Celery. And are there any questions on it?
Does it behave well with Docker?
With Docker, I haven't used Docker very much.
I can't imagine it would be a problem.
Yeah, so based on the setup that I did for those DigitalOcean instances, it shouldn't be that bad at all.
Right.
I started on a bash script to automate the whole process, but I wrote all this
bash
code today.
Yeah.
Yeah, Docker would be more ideal, but yeah, it should all be.
Docker files and starts them up, so
Right.
ages ago.
Yeah, Docker files would be.
So that would be like what would your use case for Docker be in that case for that reason?
Well, there's HPC centers that are beginning to spin up nodes that have multiple Docker instances, and
that's what Atomic does too.
So
yeah, that's why I'm asking.
So there is some use case in there.
Definitely, I just was wondering which one you were thinking of.
Yeah, I know Berkeley, Lawrence Livermore, was doing some strange things with Docker, specifically with PGAPs. So, but yeah, Docker is becoming a really big deal, at least with the people that I deal with. So
yeah, I can see like spinning up this and then sending things off to Docker instances and letting them do their job for a while and then reporting back.
There's an official Celery.
Yeah, I was kind of
Docker
wondering.
image.
Yeah.
Imagine that. Somebody was bound to create it.
When is it a good idea to break up Celery tasks into subtasks?
Into subtasks. In my opinion, the general rule of thumb is that if a task is parallelizable, then you should break it up. Because the idea of it depends on the use case. If you are expecting a result back, then you do want those executions to occur as quick as possible, so you try to parallelize as much of it as you can. If it's a task where you don't necessarily care about the execution time, you just want something done, then I would say whatever is quickest to get the job done in a nice maintainable way. So it depends on the use case, I think.
Is it a good idea to write directly to your central database from the workers to store results?
If you have a secure setup, then I don't see anything wrong with it. This setup is running on root. It doesn't have any security best practices put in, so these examples would be terrible to write to any kind of production database. But if you just like any cluster writing to your data stores, as long as you have a good setup, there should be nothing wrong with it.
Is there scalability issues with that, or?
I don't think so. I mean, there's scalability issues on either end. So if your tasks take a long time to run and they're coming in at a quick rate, you run into some queuing theory problems where if your task takes 10 minutes and they're coming in at a task per minute, then your queue goes infinitely long. So you have problems with that. Solution to that might be to spin up more broker instances, run a Redis cluster instead of just a single instance. If you need more CPU power, spin up more workers. Also, that would fix the queuing problem. If you have then the same problem where a task takes 10 minutes and they come in per minute, maybe you have 12 workers or so, so that your queue doesn't build up. If your database is taking too much traffic, probably need to scale up the instances on the database side. So it can be scalability issues on either end, I think.
Outside of performance type resources, like you just mentioned, what other kinds of problems have you run into in using it in kind of a production environment?
I have had problems where I did not necessarily configure the workers, and they would eat up way more memory than they should. So Celery is highly configurable. I just did not take the time to read deeply into that. But there are things you can cap how much memory usage a worker can have. You can cap the concurrency, set we want that to be. So as long as you thoroughly understand your configuration, it's a pretty slick piece in my opinion. And there's even control as far as like the transport format, if you want it to be JSON or pickled Python objects or XML. Celery gives you a lot of control over that.
It seemed to me when you were spinning up workers that you were assigning them a specific task to work on. Is that the case always, or is there a way to make it dynamic where we'll just simply take either a set of tasks or simply take a dynamic task whenever one comes down?
Yeah. So it wasn't necessarily that I was assigning them a specific task, but I was assigning them a specific Celery application.
Okay.
So, for example,
I was going to say the Fibonacci one was wherever tasks themselves, but it was all Fibonacci tasks.
Right. But let's say you've got an application. Can you have several tasks assigned to one application?
Right.
And then let it just pick up whatever tasks. So.
Exactly.
I
So
was understand.
I was just specifying which Celery application to use in Celery Final. But you can easily add more functions here. Just add more app.task decorators, and it'll pick up any task that is within this Celery Final application.
Okay.
So if I were to define a few more tasks down here using this decorator, then these workers would pick up any of those tasks that are pending in the queue.
But it does have to be in the same application.
Well, so you could easily just write like an abstract component on top and then do like a proxy model or pattern and just dump in whatever you want. As long as they have the same form, basically they're going to be the same. And then run all sorts of different types of tasks.
You can make it hackable.
Yeah.
That doesn't sound like a security violation to me.
It's not. As long as you use the proper pattern.
As long as
follow the rules.
As long as nobody ever actually gets access to your code.
Well, if you follow the rules, I think it's okay.
Yeah. Okay. Thank you.
Cool.
What's a good way to write tests for sending tasks out and then also getting results back from asynchronous tasks?
That's a really good question. That's
Or Python.
it's kind of the problem of testing any really distributed system. It'll never be 100% accurate because it depends a lot on things like your network connections. I have not written automated tests for Celery tasks, but I'd imagine it would be a lot similar to how I was executing them prior, which you call a task.delay. However, there would be a lot more complexity to testing it. You'd have to wait for the task to complete and verify the results. I don't think it would be too much different than standard unit testing, other than that there's a lot of other variables in play as far as like what if a worker fails.
You have to set a timeout for delay
TCP connection.
and it never finishes.
Right. So I think it follow a lot of the ideas of standard unit testing. You just have a lot more things that can potentially go wrong and be false positive or positive.
I think Celery has some either nose or Python test functionality already built into it. You can just use. I was reading somewhere about how nose can use like Celery and some other like these types of distributed systems to it does testing. It just sends them all the jobs out and it just pulls them back in when it's ready and it just like automated. So I've never done it, so I don't know, but that's where I read something about it. It's been a little while, so. There might be something there that solves that problem.
I was kind of wondering, like on mocking, if you wanted to mock
Yeah.
this, what function calls would you mock, or Would you just mock your tasks?
You
Or
probably
is
have
there
to mock
something
an
inside?
environment up front. I
Yeah.
think that'd be the
There's-
best way. Make it there and make the environment always the same on all the nodes that you're testing with, and then just use that environment as the same piece. So like if you wanted to mock up a piece of data that you're going to be using because you don't want to go make 20 function calls to do that thing, you just set all the environments to do that same thing, and then you just call when you do your test. It already has that in the environment, so you don't have to do anything. Like it's almost like, I don't know how to explain that. That's like weird to explain, but I've done mocking this way because I do a lot of distributed stuff. That's why I was thinking about it. I'm trying to think how to explain that. Because in Nose, when you write a mock, you basically write like whatever it would return, right? And that's what you're basically asking for. So you would just have to write that function call, I guess, in every one of the Celery projects that you're using that for, probably in a parent class or something, to make it simple. So that's how I would do it. But I don't know because I haven't used Celery that much. Any other ideas on that?
Yeah, I'd say that should work. Celery is also fairly extensible in that.
Yeah.
To abstractions like that. Is there any further questions? That's what I have prepared.
That was cool. Thank you. If anybody else has any other questions or wants to chat more, we can keep going. Just chat, whatever. I'm going to turn off the presentation and think. Oh my gosh. I already forgot your name. I'm going to figure it out. Derek.
Yeah.
It tells me in case on my meetup.
Oh no, you totally remember it.
Yeah, I totally remember that. That was super smooth. Awkwardness is my best feature, so I'm good with that.
Thanks.
Thank you.